Hi everyone, my name is Mo, and I'm here to talk about why do we think off-chain scaling platform is the inflection point for blockchain's mass adoption. Now I'm still waiting for my slides. Okay, here we go. Great. So before we jump into the off-chain scaling platform and the technical stuff, let's talk about something else. Let's talk about what is economic activity. Economic activity really can be interpreted as this. It is a transfer of information, it is a transfer of value, and the conversion between them. Right? So that is like what we view economic activity really is. Now, if we think about on the information side, what happened over the last 100 years? We have on the left corner of this slides, you can see a variation map, and that map is a pigeon carrier delivery network. That is how we deliver information 100 years ago. It is super slow. It is discrete event. It is not fast, right? But what happened in this 100 years is that we actually transformed from this pigeon carrier network to internet, where we achieved a continuous flow of information delivery with speed of light delivery speed. However, what happened on the value side? So that is a picture of First National Bank in Oregon State 100 years ago. And that was a drawing, not even a picture. And what happens now is that the same bank exists in the same exact place, right? So the value transfer part or the value movement part of this entire economic stack stays the same over 100 years. And that is mainly due to the, it is lagging behind comparing to the information, mainly because of there is a trust barrier to move value in this in our world today, because you have segregated financial silos that's separating them. Now we have blockchain technology. Blockchain is awesome. It brings the possibility to conduct value transfer between untrusted parties with arbitrary contractual logic, right? So think about a smart contract, the Bitcoin, EOS, and all that awesome stuff. But what is the problem now? The problem is that it is actually that slow, right? The entire value transfer speed is dropped back to a very, very low speed. Okay. So we all know that blockchain has all these great promises, but you cannot support all these great applications on the processing power of a smartphone, of a Nokia phone in 1999. So we need scalability, and we need it right now, right? We all know that. But let's calm down for a moment and think about this question. What is our end goal here? We are talking about scalability, we're talking about we want to make blockchain faster, but what is the end goal that we finally want to achieve? Right? Many people say that, okay, the blockchain scalability should reach to the level of Visa. And I say that that is a completely wrong statement. Right? So our goal here is, as we talk about how economics works, is to let the value transfer match the scale of internet information transfer, to make the value transfer as fluid as the information transfer and fast as the information transfer. Now, how fast is information being transferred today? We're delivering 2 million emails per second, 65K Google searches per second, and 72K YouTube video played per second, and 53 terabyte data delivered over the internet in just 1 second. And we're looking at about 8 to 10 transactions per second on blockchain. Now, let's just do a back-of-envelope calculation here and say that we have about one transaction or one value transfer is associated with every 1,000 kilobyte of data delivered. It is not to say that we're going to bring email to blockchain. We're not saying that. We're just saying that to reach the same level of fluid transfer of value, we should be looking at about 530 million transactions per second. That is our final goal. That should be the goal this entire community is targeting. Okay, 500 million transactions per second. That is super scary. How could we even ever get there, right? So this is how the blockchain architecture works. You have an underlying blockchain, and you build a decentralized application on top with the user front end, and use the blockchain as a backend database. And there are a lot of awesome work happening in the blockchain scaling space to scale out or to scale up or out the fundamental consensus algorithm in the blockchain underlying layer. And we're about there. But the problem we see in the future is that we have diminishing return if we just focusing on the blockchain layer, right? We just focus on the consensus layer. The reason for that is because it is in the end of the day, still a consensus algorithm. And a consensus algorithm has an inherent overhead in the communication delay. And therefore, it is very hard to achieve, scalability beyond the processing power of a single machine. Even if you have sharding, there are different kind of trade-offs being made, and the worst case of a performance is still bounded by the processing capability of a single machine. Now, we can see there's like an on-chain scalability limit right there, but as we talked about, the ultimate goal here to reach mass adoption is much higher than what the on-chain scalability can offer. So what we need here is to actually now let's think about it. Why can internet be so scalable? Because on internet, when you're browsing a web page, you're not reaching consensus with all the users on the internet, right? So we take this same kind of a high-level intuition and we say that, okay, how can we bring most of the transactions from blockchain to off the blockchain while still maintaining the security property of this entire blockchain system? That's what the off-chain scaling platform is all about. And we believe that is going to be the actual inflection point for mass adoption for blockchain technology. And that is going to bring us to the final goal for that really high transaction scalability. Now, how does off-chain work anyway? Right? The concept or the basic techniques that people talk about these days are state channels and sidechains. It is really fast because there's no consensus involved during the transaction. Only the related party need to be agreeing on the same thing. It is still very secure because you always have this on-chain bond contract to govern the final settlement if the dispute happens. Now, however, people always talk about off-chain solutions as a term called layer 2. And I believe that is also a very, very bad term because that kind of put a thinking on this entire stack that it's an optimization. Well, it is not. Okay, so this entire off-chain platform is a very rich stack, both on the technology front and also on the economic front. So the project I'm working on called Celer Network is providing this coherent off-chain architecture on both these sides. So I will just quickly talk through them. So on the technology side, we proposed a layered architecture called C-stack. And in the lowest layer, we have a thing called C-channel. What C-channel really is it is an off-chain abstraction that supports generalized decentralized applications beyond simple payment. It combines the capability of state channel and sidechain and enables a multi-hop state relay that you can do very complicated off-chain transitions with multiple parties without actually repeatedly incurring any kind of on-chain transaction complexity. And it also comes with a formal specification and verification possibility to enable the off-chain application to build in a very secure way. And most importantly, this layer enables the Celer network to become a blockchain-agnostic platform and enables interoperability between different blockchains. No matter what is the underlying blockchain, we always have the capability to plug into this blockchain and bring scalability on these platforms. And on the C routes, and on top of the C channel, we have C route. Now, basically consensus algorithm is the performance engine of the blockchain, but what is the performance engine for the off-chain platform? Now, that is like a state routing algorithm, and we proposed the world first provably optimal state routing algorithm that surpassed any existing algorithm in performance by 20 times. And it also enables transparent channel balancing, high failure resilience, and it's still fully decentralized algorithm. There's no need for a central entity. And on top of that, the performance engine sits our application engine. So finally, we want to bring transactions and we bring applications to our platform, right? So we built a developer framework for what we call C-app, which is like a decentralized application built on this off-chain platform. And we also enable the bridge of the on-chain and off-chain bytecode that you can basically execute the same kind of bytecode on both places. And we really give a easy-to-use user runtime. It enables this kind of a look and feel of using a Wi-Fi network where you pull out a cell phone app and just connect to the Celer network, and you start to use this super awesome application with good user experience because of the very, very scalable. Now, okay, so I've been talking about like the entire technology architecture, and I'm making big claims about scalability. Now, what is the catch, right? So what is stuff that I'm hiding here? Well, so scalability doesn't come for free. Scalability always comes at a cost. Now, what are the costs? So the first cost is that for any off-chain scaling solution, no matter whether you're using sidechains or using off-chains, there is always this trade-off of scalability versus liquidity. So you need to lock in a lot of liquidity upfront before the transfer start to become like a super scalable. And there's also the assumption of scalability versus availability in the sense that since it's not always a blockchain that reaches the entire global consensus, you always have the responsibility to maintain, track, and store, and maybe dispute the state for yourself. Right? So not like everyone is responsible for you, it's just you are responsible for yourself. Now, what happens if you drop offline, or if you're just IoT devices that need to go offline to preserve energy? Okay. So there are some trade-offs, but that's fine. That is what crypto economics is about, right? So there are many projects talking about like a token model or introducing a different kind of a crypto economics, but what is the principle of a crypto economic construct is to use a token model or incentive model to be part or to be an integral part of the system and bring extra value to the system, like which is not possible if we don't have this kind of a crypto economic construct. And Celer network provide exactly that. So on the economic construct side, we have a principally designed off-chain crypto economic construct called cEconomy. It consists of three components, one called the proof of liquidity community mining, and the other is liquidity backing auction, and the third is the state guardian network. And for the proof of liquidity community mining and liquidity backing auction, they together solve the challenge of the scalability versus the liquidity trade-off. So the proof of liquidity community mining incentivizes the system to lock in an abundant and stable liquidity pool. And the liquidity backing auction essentially enables the possibility to do crowdsourcing liquidity, and it will also, in the process, reward the liquidity backers who committed their liquidity to our system in the proof of liquidity commitment phase. And it still ensures 100% safety for the end users. So we also have the capability to solve the trade-off bring by the off-chain scaling solution, which is a scalability versus availability trade-off, where we have a state guardian network that is a decentralized monitoring or sentinel network that helps you to guard your state, and it's secure and collusion-resistant state guarding. It has a unified state interface, so you don't need to care whether it's value state or a programmable state, or there's no liquidity lockup needed for the state guarding process, and it brings this kind of a new and flexible economic dynamic that you can freely choose how secure or how much you want this state guardian to be responsible for you. Right, so this is like a very high-level overview. We have a very detailed description of all these things in our white paper and also in our Medium blog post. So with Celer network, what we can do is that we transfer that slow value transfer capability between untrusted party with contractual logic to speed of light value transfer between untrusted party with contractual logic. And where Celer network sit in this entire stack is Celer network is connecting to different blockchains, and Celer network is also acting as the entry point for all the blockchain applications who want to use the scalability platform or scalability capability provided by Celer network. So with Celer network together, we can bring internet scale to every blockchain. So that is my talk today, and I really want to raise the awareness of the importance of off-chain scaling platforms. So I do have some question to some time to take a few questions. Any question from the audience?
Yeah, thanks for sharing. So just one quick question regarding the off-chain operation, right? Let's say so my understanding is that somebody makes a transaction and then post transaction to the chain, right? So we only posted the final result to the chain for validation. If that's the case, that let's say if I buy something from another person, we post the final result, how would that be verified on the final chain, just from the technical perspective or from the governance perspective?
So let me try to repeat the question. Like what you're asking is, if we have like multiple applications running on this blockchain, and how to ensure that they're not conflicting with each other.
Now, my understanding that for off-chain, right, basically that the on-chain will not kind of process the entire transaction, right? It just post the final result.
Yes. So the possibility to make that secure is because that we always have on-chain bond contract, and even though you're not like posting every transactions on the blockchain, in the process of off-chain transaction, you always have the capability to record what is like the proof or what is like the each steps during this transaction, and or what is like not steps. What is the state snapshot for each of the step, and when the worst thing happens, you can like basically revert to the chain and provide the step, and the chain smart contract will like process that with utmost faith, basically.
Okay, got it. Thanks.